Hey guys, I found a really cool trick in math, and it specifically deals with binomial theorem. So x plus y or x minus y to the power of z. That's basically binomial theorem. So we can have something, let's say 2a plus 3b, and let's say to the power of 7. And you want to do it real quick. And the classic way of doing it is 2a plus 3b, and then multiply by 2a plus 30b. And you go dot dot dot. You're gonna go 7 times. That's the classic way of doing it, where you take the first, outer, inner, last, and you multiply by that. And usually it takes a really long time when you're doing numbers as big as to the power of 7. And I wouldn't be surprised if it takes like 15 minutes to do the whole thing, which is really long time. However, Algebra 2 and Calculus would teach you another way of doing it, which is by combination, where you have NCR equals to n factorial over r factorial n minus r. And that's a way that basically algebra and calculus teach you to do it. And it's a lot better than this. It's a lot better than doing it this way. So, but however, I still think it's a tiny bit slow. And I have figured out my own way of doing it, which I think is a lot faster. But for those of you wondering what is this, I'm going to teach you guys what this actually is before I teach you guys my way. So just so you guys can compare. Okay. So NCR, the C stands for combinations, and n factorial. So I'm gonna give you an example of this kind of question. So you can have like 5C30, for example, and factorial sign, it's basically the number, the n, multiplied by 1 less than the number, all the way till it reaches 1. So basically, 5 combination 30 is basically 5, which is the n, and when it's factorial, it's multiplied by 4. Multiplied by 3, 2, 1, over, and then this, here's the formula, it's 3 factorial, which is times 2 times 1, multiplied by 5 minus 3, which is 2 factorial, so 2 times 1, which is 2. So basically, this whole thing is simplifies to, let's see, 1, so 2 times 3, 6, 24, 24 multiplied by 5 is 120, over 2 multiplied by 3 factorial, which is 2 multiplied by 6, so 16, is it? 2 multiplied by, actually no, there's 6, so there's 12, so it equals to 10, basically. So the first term, so this would equals to 10. That's what's saying. So, and the thing, so you might be wondering, how is this helpful to solving binomials? Well, let me show you guys what the binomial theorem is. Okay, so the binomial theorem is NC0 AN plus NC1 AN minus 1 B plus NC2 AN minus 2 to the B, and this is B, so this is a B to the power of 1, and this is a B to the power of 1 plus 1, which is power of 2. But basically what this is the first term is gonna always be NC0, which is 1, and then A to the power of the whole exponent. So basically, if you want to take it technically, it's like x plus y, but to the power of n, and that's what's n representing. And the next term is going to be this, NC1, where it's gonna be hard to explain what it is. You're gonna have to learn algebra yourself to actually know what this is. But it's basically choosing one out of all of these terms with no arrangement, which you'll learn once you get to algebra 2. And you're gonna n minus 1, so this term smaller than itself, while you have the b value, which is right here, which is the y to the power of 1. That's where it shows up. And as this drops down, so as this drops down, the 1 is going to be plus 1, and it's going to keep following that pattern, and that's the binomial theorem. So let's do one real quick. Let's take the previous example, or I don't know. Let's just take the previous example. So 2a plus 30b to the power of 7th. Let's do this one right here. So n, which is this, which is 7, c0, the 0 is given to us already, a to the power of 7. And it's basically saying so we gotta use this formula they've given us, or yeah, right here, the formula is right here. We're gonna go which is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 0. So it's 0 factorial, which is nothing basically, multiplied by 7 minus 0, which is 7 times 6. So it's 0 multiplied by 7 times 6 times 5 times 4 times 3 times 2 times 1. Actually, this is 0. Actually, this 0 doesn't exist. Sorry. Basically, this is this over this, which equals to 1. And it's 1 and the a term is this, so 2a, 1 multiplied by 2a to the power of 7. So the first term is just the first term is just 256 to the a 7, if you don't want the parentheses. So you basically see this whole process. It took me like 3 or 4 minutes to just do one, which isn't to do. This is only the first term, and for something like to the power of 7, you can expect n plus 1 terms. So you can expect 8 terms. So it's gonna take, if we do it this way, it's gonna take like 15 minutes to still do the whole thing. And fortunately, I figured out a faster way of doing problems like these. So I'm gonna show you guys. Sorry, I just ripped it. But I'm gonna show you guys a faster way of doing these problems. But first, you gotta understand the Pascal's triangle. And I know what you're thinking. No, we're not gonna use the Pascal's triangle. But I need you guys to understand what the Pascal's triangle is, so I can show you guys my formula. So with Pascal's triangle, you start with 0, 1, 0. And then 0 plus 1 is 1, 1. And 1 plus 1 is 2. As you can see, we're just adding the 2 top ones to get 1 bottom one. And let's keep going. And pretend there's a 0 right here. Obviously, we're not going to draw the zeros in the actual Pascal, but we got to pretend there's a 0 at each side. So this is going to be 1, 0, so it makes now 1, 1. Now 1 plus 2 equals 3, 3. And pretend here's a 0 here. 1 plus 0 is 1, 1. And the pattern goes on. So let me just clean this off a bit so that it gets cleaner. And we'll show you guys. So we're going to go all the way to the x plus 1, y to the 9th term, so that we have a line of 10, a row of 10. So we're going to have 1, 4, 6, 4, 1, 1, 5, and then here is 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. So that is to the 1, 2, 3, 4, 5, 6, 7, 8. That's to the power of 7. Yeah. 1, 8, 28. So 28, 8, 1. We're gonna go 70, and this is 56. 56. That's to the power of 8. We can't tell by the second term, but basically 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. Okay, so that's to the 9th power, which give us exactly 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that should be enough to work with. And basically, yeah, you see what's going. 35 plus 37 equals 5 equals 70. And then 70 plus 56 is 126. And you're like, yeah, I get it. And you probably would have already learned this in, I don't know, 8th grade, 9th grade. So the concept should be pretty simple to you if you're watching this video. But here's the thing. Have you ever, instead of going down, okay, have you ever looked from left to right? How does this number get to this number, and it back? How does this number go from 1 to 9 and 36? I mean, it doesn't follow a pattern, because 1 times 9 equals 9. And then 9 times 9 doesn't equal 36. It equals to 81, which 36 isn't even a factor of 81. I mean, 1 plus 8 equals 9, but 9 plus 8 doesn't equal to 36. In fact, 9 times 8 to the power of whatever doesn't equal to 36. Well, that's why you gotta look a tiny bit closer. Let's start off from this one, the easy one, 1, 2, 1. This is 1 times 2, okay? And then to get from 1 to 2. And then what is still going on? It's times 1/2 to get back to 1. Okay? So, okay, now look. 1 times what? 1 times 3. Okay? And then there's a 3 times 1. And then there's 3 times 1/3 to get back to 1. And this is times 1. So times 4. And then what is this? This times 1. Okay, so times 1 and 1/2. And this is going to times. This is going to times 2/3 and times 1. Actually, no, times 1/4. And that is just how this pattern works. And as you can see, you might be getting frustrated. Well, there's no pattern right here. I mean, times 1 and 1/2 and times 2/3, that's not really a pattern that's helpful. Now, is it? Now, here's the cool part. So we're going to erase everything we just did, and I'm actually going to tell you what it actually is. It's actually really close to what we just did, but we're still not thinking the right direction. Okay. So the one on the left are always 1. The first and the last digit and the last term, it's always 1. Okay? It's just, so if it's just 1 times, this is a to the power of n, and this is 1 times b to the power of n. That's it. You know that. And this one, the second